Here we'll inspect the graphs of logarithmic functions. For our first graph on the left, we have y equals log x. If we examine this graph, we see that the graph starts out coming in from negative infinity at this position I'm circling in green. It starts out increasing rapidly, but begins to level off over here on the right, and so you end up with a diagonal arrow on the right side. First thing we'll notice, though, is that this graph runs along the y-axis and never passes through it. And so what we have is an asymptote here right on top of the y-axis. This asymptote is pointed vertically, and so we'll label this as a vertical asymptote. And we'll also note that this is where x is equal to 0. The reason why you end up seeing this asymptote at 0 is because if you try to plug either 0 or a negative number into a logarithm, you get what's called an undefined answer. This is something we'll cover in the course near the end in Unit 4. But for the moment, it's good enough to realize that an undefined answer will not appear on the graph. Now, since plugging in 0 would also give an undefined number, our domain cannot include 0. Therefore, if we were to draw this domain, we would make a number line that has a dotted line at 0, and then we're going to cross out the left side because we know the graph can't go there. However, everything coming after 0 is okay. We can put positive numbers in a log function, but we'll put an open circle at 0 to show that we're not going to include 0. Therefore, this domain will go from 0 to infinity. We will not include 0, so we'll put a parentheses there, and of course infinity isn't a number, and so we'll put parentheses there too. For our range, we may be able to see that there is a down arrow near the asymptote. Therefore, our range will begin from negative infinity. And on the right side of the graph, we may be able to see that this arrow is going slightly diagonally up. It's okay that it's only slightly up. We still treat it like an up arrow. Therefore, eventually, albeit slowly, this arrow will eventually reach positive infinity. Therefore, we'll say our range will go from negative infinity to infinity. Now to find f at 2, we can circle 2 on our x-axis, place a dot, and try to read the y value. It's a little bit difficult to read this one, but we'll label the 1 on the y-axis and the 0 on the y-axis, and we'll note that this line is about 1/3 of the way up from 0 to 1, so we can estimate this at about 0.3. However, to verify this, we can go to a calculator and find log of 2. So we can say 2 and then log, and we get 0.301. For the moment, that's good enough for our purposes. We'll dive deeper into the math in a later unit. The squiggly equal sign means that this is approximate. Now we'll try another graph that says y equals ln of x minus 1. If you see the letters ln, that means natural log. Now, natural logs are a little bit more complicated, but for the purposes of domain and range, they behave the same as other logs. Again, this is something we'll explore more in a later unit. For our domain, we'll start by locating our asymptote. We can see that there is a wall the function appears not to pass at x equals 1. That will be our vertical asymptote. When we write our domain, we'll indicate that the asymptote is at 1. We'll put an open circle on 1. We will cross out the left side of the graph to show that the graph will not pass that 1, and then the rest of the graph is okay. Since we do have a right arrow, as with the other logarithm graph, that right arrow represents positive infinity. Therefore, we'll say our domain goes from 1 to infinity with parentheses on either side. We can also notice that the general shape of the graph is the same. The fact that we changed log to ln does not change the shape of our graph that much. And notice that we still have a down arrow and an up arrow. Once again, the down arrow represents negative infinity, the up arrow represents infinity. Therefore, our range is negative infinity to infinity. And if we look for f at 2, we notice that at 2 the graph is directly on the axis. If the graph directly passes through the axis at that position, we can say our answer is 0. This is how we examine the domain and range of logarithmic graphs.